Hi everyone, I'm Philip. Today I want to continue our series and I'll build on what we've been doing the last few sessions and try to combine it. So just as a very quick repetition from before, we had a query where we had a match or a multi-match and we ran that query and we got our results back. So I'm using the same query as the last 2 days. I don't know how to use ingest pipelines, limited to the top 6 results. I'm only showing you the title field to make that a little more or easier to read, and I'm excluding also the source. And I'm just matching on the title field here. And you can see I get my 6 results back, and the top query has a score of 17.7 something. So far, so good. We have seen that. We have seen the same thing with the dense vector queries. If I run this query, the results are slightly different. Also very good, but what is totally different here is the max score, 0.95. And then we also have the ELSA queries that we've been running, again, with the same query and otherwise the same setup. Again, the max score is very different again. Why am I focusing so much on the max score? If we try to combine these queries, and I'll show you in a moment how to do that, how do we make sure that the results are combined correctly, or that the weight of each different query, if we combine multiple ones together to get better results, makes sense? This is pretty much the point of this entire session, to combine the different types of queries and make the most out of them in combination. So let's see. Here I'm running a query on my dense vectors, and I'm running the KNN search that we have seen 2 days ago and just before now, combined with the very first query we ran, the multi-match. So we have a classic match query plus a dense vector query, and we combine those. Now, just for comparison, if I run the first query, it had the max score of 17.7 something, and it had like how to use ingest pipelines in Elasticsearch and how to use pipelines, etc. Now, if I run the combination of these queries and the KNN query only had a score of 0.9 something, the score, but also the sorting, is very similar to just the multi-match query. The combination is actually, we just run both queries and then sum up the dense vector score and the match score. And since this one here is much higher than the other one, the influence of the match score is, of course, higher than of the KNN score, which might not be what we want. Maybe we need to tune that and want to say like they're maybe a bit more equal, or like the influence of the dense vector query should be higher. What would be the solution to that? The answer that most people will give now is we can boost. So for example, here, this is again the same query that we have used before. I'm just boosting by 0.9 the KNN query and by 0.2 the other one. You could also just boost one of them. So for example, we could skip this one and keep the implicit boost of 1 and then boost this by 2 or 3 or whatever a sensible value is. And then we can run the query, and you will see now the order changes. The influence of the KNN query has increased by quite a bit. And the underlying formula, of course, is each score multiplied by its boosting value, and this is the overall score that we're getting out of this. So far, so simple, but this is not necessarily a great solution. The problem is the score for each query very much depends on your query and data set. So the boosting of 0.9 and 0.2 is kind of like, I looked at the first queries and said like, well, this is what we got out in the max score for each. If we combine them, this is maybe an approximate value. So it was not A, very scientific, and B, it depends very much on your data and how you query, how the boosting potentially combines the scores in a more reasonable way. But there are better ways. And the better ways is what I want to show you today. So the underlying thing that we have implemented in Elasticsearch is Reciprocal Rank Fusion, or RRF. It has a paper. The great thing about the paper is that it's very short. It has exactly 2 pages. So it's pretty easy to follow along. And the gist is, this is the relevant formula. which looks still complicated, but it's actually very simple. Let me walk you through the formula. So what you do is, if you want to combine multiple queries, you run each query, you rank the documents in each query, then you calculate the reciprocal rank for each query. So for example, the first document in one of the queries gets a value of 1 divided by 1 plus k, and the k is a ranking constant. The paper explains that 60 is the value that they found out makes most sense. You can change that. Probably you're just making things worse. So by default, I would leave it unless you have a good reason to change it. So it's 1 divided by 1 plus 60 for the first rank. The second one is 1 divided by 2 plus the k value, etc. So you get this reciprocal rank for each document. Next up, for each document, you sum up for each of the queries the ranked value. So for example, if a document was the first one in one query, this is the value you would take. If it's the second one in another query, you would add that value together. And then you sort all your documents by those calculated sums. Just to give you a made-up example, let's say we have 5 documents. Here, for easier calculation, I'm just using a value of k equals 1. And then we say the regular query that we have been running has the values of like document 4 was the first one, 3 the second one, 2 the third one, and 4 document 1 the fourth one. So we have the k of 1 in our example plus that ranking. For KNN, the order was 1, 2, 3, 4 these documents. We calculate each ranking function or ranking score. We sum them up. We have the total scores, and at the end, we just sort by the highest score. So 0.833 is the highest score. So this will be overall the document with that we spit out first, basically. This is what RRF does. So it doesn't look at the actual value of the score. It only cares about the position that you have. So how does the underlying query of that looks? So we just take the query that we have been doing before. We say we want to rank this with RRF. We can optionally set a window size. A window size is basically how many sub-results of each query do we calculate. It would default to 100. So I overwrite this in this example. So we would take the first 60 documents from this query and rank them. We would take 60. I've also changed that k value, otherwise it would be cut off. The first 60 documents from our KNN query and rank them. Then we combine them. And then the rest is again the same of what we've been running with the queries. So if we do that, you can see the change here. Multiple pipelines for ingest node is for the position in combination of these queries is the same. If you want to combine not just a KNN query and a query, but you would want to combine 2 queries, normally to combine 2 queries, for example, you want to have a regular match query and an ELSA query, you would combine them in a bool query. This doesn't work here because we need to rank them separately. So to do that, the syntax is slightly different. KNN supports or has the support for sub-searches. So here is an example where we combine 2 different queries together. So we run our multi-match and our ELSA query. Otherwise, we just use RRF for ranking again. I don't provide the parameters. We're just relying on the defaults of the window size of 100. And when we run that query, it will again rank in the background and return our results. Now, a couple of things to note before we close this out. First, if you use RRF today, you don't get a score back, which is probably confusing. So you can see max score is null and each individual score is null because it's based on the positions. I still think that sometimes for debugging, the calculated sum could be helpful, but at least as of now, we don't return the value. The second thing is the implementation of RRF as it is today. The syntax will probably change quite a bit since we will re-implement some parts of that to make it a bit simpler. So while this is the query syntax that you can use today in 8.10 and some of the previous minor versions, it's probably going to change, so don't be confused by that. And the final thing is we don't support all the features that you would expect here. So for example, you cannot do and explain. You cannot paginate. You cannot use a point-in-time query. There are a couple of limitations around your queries that with RRF you cannot do right now. But the big advantage is you don't have to manually boost anything, and you don't need to know the score of your queries to make them combine together, but you really rely on the ordering of each individual query to blend them together. That's the gist of RRF. And as the paper has shown, it is doing a very good job of getting good results without any specific tuning or machine learning model behind it, just by taking the individual results and combining them. And that's really the gist of what RRF is. If you want to copy and paste any of these details, and we'll share it in the slides afterwards, I threw all of that in a gist, so you can just copy paste it or look at the details, including the explanation in the paper for RRF. So you can get started with that. Thanks a lot for joining today. See you tomorrow.